Hello class, and welcome to this video in which I will show you how to use CircuitsU to perform source transformation and to learn about the concept. So the first thing that we need to understand about source transformation is that it is always with respect to two terminals, and we have two canonical or two default forms for the source transformation. So the first one is the voltage source in series with the resistor, and then you have the equivalent circuit, meaning that they behave the same, electrically speaking, the current source in parallel with the resistor. So notice here that I'm drawing the two terminals explicitly because this will tell us how to or where to perform the source transformation so that we can make a valid transformation. So here will be our voltage source, here will be our resistance, and then here is our current source, our resistance, and then the voltage source is equal by the current source times the resistance. If you want to go, let me be a little bit more clear. If you want to go from, let's say, current source to voltage source, it will be the voltage equals I times R, and the R remains the same. If you want to go from the voltage source to the current source, it will be I equals V over R, while the resistance stays the same. So notice here that it's being with respect to terminals A and B, so we need to grab quote-unquote a chunk of the circuit and then make it into its respective transformation. So in this case, it says to simplify using successive source transformations and parallel simplifications to bring the network to a single source and a single resistance and compute I/O. Okay, so the first things first is to find any of these forms in our circuit so that it can be simplified. So in our case, this is I/O, and we know that the current in a series circuit will remain the same. So that gives us a hint onto how we can simplify the circuit more. So now I have here, this pops into my eye, the current source and this resistor. So I think it will be best to do source transformation this way, and then I need to know how to perform it or where our terminals A and B are. So here, if I were to put these terminals like this, just before the voltage and just before the 10 ohm resistor, then I would have a little box here that will tell me, oh, this circuit or this part of the circuit is the same as the current source, which is what we have here. So then we can combine it into a voltage source. Now, the orientation is very important because notice here that since we are using, of course, the current in parallel with the resistor, notice that the current in the circuit goes down. So in this case, I can write down, again, with respect to terminals A and B, we grab this chunk of the circuit, and then we can write a voltage source. But here, since it goes down instead of going up, based on our canonical form, then we need to put our voltage source the other way around so as to preserve the current by the passive sign convention. And then we put our resistor here, and then notice that this is where our chunk of the circuit has been transformed, and then the rest of the circuit is going to be the 5-volt source and then the 10 ohm resistor. So this is what we're going to do. So the way that this will work then is going to be V equals IR, so it's going to be 2 times 4, which is going to be equal to 8 amperes, and then the resistor stays the same. So this is what we're going to be doing. So how do we do this in CircuitsU? Well, let's just go into the circuit here. I will clear some of the drawings, and then I will select my current source and my 4 ohms resistor, and then I'm clicking on source transformation. Now it's going to give you a small window, let me erase more here, where if you notice, there's the chunk of circuit that we just did. Let me just redraw it a little bit easier for you. So remember, we had the 4 ohms here, then the current source, then our voltage source, then our resistor, and then notice that we have grabbed this chunk, and this is what is going on here. the rest of the things or the rest of the devices should be something like this when we do our transformation. So then we can drag and drop the elements, and notice how there are little gray lines making kind of like a grid. So we need to make this circuit from the current source to the voltage source. So we click here on the resistor until it shows a little 4 arrows so that we can move it, and we move it across the grid. And then here I will move this voltage source, and then I'm going to drag it like this. And then notice that for some reason CircuitsU made it so that it's minus plus like this. So I will double click to flip it, where it says here double click on a new component to flip it so that it goes into our direction. And then we click on the grid lines to add or remove wires. Notice that I clicked a little here and then a red line appeared. So this is what I'm going to be doing in between the terminals. In between the terminals of each circuit, I will click on the grid to draw the lines. So this is what we got, and this is the transformation. So our resistance, which is still going to be 4, and then our voltage, since we have the same orientation, is going to be 8 volts. So we submit, and yeah, it is correct. Excellent. So the next thing is to, now that it is in series, it's very easy to compute the current. However, CircuitsU lets you practice simplification, because it's a really important concept in circuit analysis and circuits in general. So we need to combine the elements in series now. And the nice thing is that, again, the current is the same in a series circuit, is the same across each element in a series circuit. So in our case, I have the 8 volts and the 5 volts combined. Notice that, again, by the passive sign convention, the current enters through the negative terminal and it exits through the positive terminal. So this means that, and since they are in series, they can combine in series, so we can just add them up. And not only that, but if we were to follow the convention, we will see that both sources share the same sense of direction of the current. This means that we will add them up, or we can also flip the terminals and put the negative of the addition. So in this case, what I'm going to do is I'm going to click on these, and then I will combine them in series. So I will quote unquote eliminate one source. Let's say we eliminate the 8 volt source with a short circuit, and we will replace the 5 volts with the equivalent voltage source. Now, what will be the answer? It's just going to be 13, because again, the sense of current makes it that both of them will add up. So let me put here 13. Let me submit, and it is correct. Then finally, we can just combine the elements here, this resistors in series, so that we have 14. Then we submit, and then finally, we can obtain the final current. We just have to be careful about the sense of direction of I/O. And I/O goes like this, the little arrows. So in this case, the current will have the same sense of direction as a voltage source, so it's positive. So then it's going to be V over R, which is 13 over 14. Now, the nice thing about CircuitsU is that it lets you just put the fraction here, and then it will give you the answer in decimal form, or you can also use the decimal form here. And this is how you do a source transformation, a simple source transformation using CircuitsU. If you have any questions or comments, please let me know. Thank you very much for watching, and keep practicing.